Hey, it's Stephanie, your pre-med BFF, here with your daily dose of pre-med motivation. Today we'll be talking about solving trigonometric equations. So if you're in pre-calculus 2, I'm having a feeling that you're probably feeling like these are a little difficult. Teachers usually say for every hour in class, try and spend 2 hours outside of class working on the material, and for this it's especially true. If you try and cram it all at the end, right before finals, it will be a lot more difficult than if you're practicing along the way. Today we're going to be looking at a problem from Blitzer's textbook, which is the one I learned from. We're going to be looking at question 59, which is on page 675. But in the back of the textbook, they do have answers. I checked all of my answers and they're all correct. The reason why I'm doing a tutorial for a problem like this is sometimes finding a solution isn't so intuitive. The more you practice, the easier it becomes, but you need to train your mind to look for these little ways to solve the equations. And we'll just be looking at one of the ways that you might encounter. In the back of the textbook, they will tell you the answers, but they don't tell you the steps. And so I'm just listing my own personal steps to help anyone who's struggling or anyone who just wants a refresher. Enjoy! So for a problem like this, we're going to be examining it on an interval of 0 to 2 pi. And that means we don't include 0, but we will include 2 pi if it is a possible answer. Okay, so we've got our interval, we've got our equation that we're solving for. So our first step, this looks very problematic, correct? Maybe you already know where to start, in which case there's more videos for you to enjoy. If you do look at this and feel a little perplexed or stumped, it's good to notice that both terms have, I guess, what would you call it, like a like term? This is a similarity. So since it's addition, we can pull this out from both terms. What we can change this into, we can rewrite it as sine x multiplied by, and then what would this be? Just 1 plus, and then this, if we take sine x out, it's just going to be 2 cosine x, and again we can do this because sine x is being multiplied by each term. Okay, now this is all going to equal 0 still. And now when you see two items being multiplied together, you can set each one equal to 0. So now we've got a rewritten equation of sine x equals 0 and 1 plus 2 cosine x equals 0. So that's what we're working with. This, and we have to find it on the unit circle. So we draw our unit circle here. This one is a little bit easier than this one, or maybe this one's easier. It depends on what's your preference, but both are actually relatively easy. We can work through it. So here we've got our quadrants, and we're looking for sine x equals 0. So this right here, this point right here, we're going over 1 and we're going up 0. And do we remember what signifies cosine and sine? Right, this is cosine here, and this is sine here. So in this circumstance, right here, this dot right here, which could be 0, and again, it can also be 2 pi. We're omitting 0 because we're just looking on an interval of 0, not including 0, up to 2 pi. So we omit 0 there, and we're just looking at 2 pi. That's a possible answer. Valid answer, that's our first valid answer, because sine is equal to 0, and that is our stipulation there. So that's our first answer. Good. Now, over here, we're going over -1 and up 0. Again, sine is equal to 0. So in this circumstance, we're also going to see a valid answer. The valid answer here being pi, right? Good. So that's our second valid answer. Now I'm going to hop over here and let's look and see if we can find some valid answers over here. So we're looking for what cosine x is equal to. So we're going to try and move the numbers over to the right side of the equation. So we're going to subtract 1 from each side, giving us 2 cosine x equals -1, right? Now we can divide each side by 2 because we're trying to isolate cosine x. So that cancels out, and then we're left with cosine x equals -1/2, right? Now what does this mean? Is anyone drawing a blank? Don't worry if you are. Let's just follow along and see if we can make sense of this. So what does cosine mean? Cosine is adjacent over hypotenuse, right? Because remember the SOHCAHTOA, right? SOHCAHTOA, sine, cosine, tangent. This is how you find what they're equal to. So we take the adjacent, which is going to be 1, over the hypotenuse, 2, and the hypotenuse is never going to be negative, right? Hypotenuse is never negative in a unit circle. We go to our unit circle, we build our quadrants. Remember when you were learning about, you have up here all signs are positive, over here sine is positive, down here all students take tan is positive, and all students take calculus, cosine is positive. So that's an acronym for how to remember what is positive and what quadrant. So all of them are going to be positive, all sine, cosine, tangent in the first quadrant, and the second quadrant is just going to be sine, the third quadrant is going to be tangent, positive, and the last one is going to be cosine, positive. So we know it's negative cosine, so we can know this is not going to be valid here because cosine is positive, and up here they're all positive, so this is not a valid answer either. So we can cancel those out of the equation. Now we're going over -1, right? -1, and we're going up, and you never build that way, right? You're always going out from the center point right here, out. And so this is going to be coming down, and we know our hypotenuse is 2. And so then what would leave that remaining side? Do you remember on your triangles? This is going to be square root of 3, right? Yeah. What kind of an angle is this? Do you remember this angle right here? 60 degrees, right? Good, good, good. So how do we know what these two are? A 60-degree triangle, right? So we have one here, 60 degrees, right? And we have one down here, also 60 degrees. So that's the same thing as saying pi over 3, right? But since this one, all right, so this is pi right here, right? This would be pi right here. And we're going back pi over 3, so we can subtract pi over 3 from pi. So this is actually going to be 2 pi over 3, because we're taking pi, which would be 3 pi over 3, and we're subtracting pi over 3. And that's going to equal 2 pi over 3. Down here, we're adding pi over 3 to pi, right? And so this is going to be, go ahead. Right, 4 pi over 3. You got it. Good job. Okay, so now we've got these two answers, and Now you've finished your equation. You finished it. X equals, and then you would just put 2 pi over 3, comma, pi, comma, 4 pi over 3, comma, 2 pi. And there you have it, folks. You've officially solved a trigonometric equation that looked a little bit difficult to solve. Good job.